Welcome to the deep dive. Today we're looking at an engineering assessment report for a natural gas pipeline.
Okay.
Sounds a little dry, right? But trust me, this one's got intrigue. This pipeline's been sitting idle for almost a decade, and now they want to bring it back online. But as this report reveals, it might be more complicated than just flipping a switch.
Yeah, you're right. This report highlights a challenge the energy industry faces more and more these days. What happens to pipelines that are shut down for long periods? Because as we're seeing, out of sight doesn't necessarily mean out of danger.
So let's set the scene. This pipeline, located in the Kaybob South field, carried natural gas and was discontinued back in 2015. It's been dormant for over 9 years, and now the company wants to reactivate it. And that's where things get interesting. The report points out that the original discontinuation process back in 2015 wasn't entirely by the book. There are gaps in the records, especially around how they managed corrosion during the shutdown.
That's a red flag right there. Corrosion is a pipeline's biggest enemy. And if it wasn't properly controlled during shutdown, we could be looking at some serious issues.
The report actually uses the phrase severe pre-existing corrosion damage to describe what they might find. And let me tell you, that's not something you want to see in a report about a pipeline you're about to reactivate.
You're kidding.
The report spends a lot of time on the potential for internal corrosion. They categorize the risk as serious, estimating that the pipe walls could have thinned by 20% to 30%.
Wow, that's a lot. What factors contribute to this high level of internal corrosion risk?
The report points to a few culprits. First, the type of steel used in the pipeline itself. Some steels are more prone to corrosion than others. Then there's the composition of the natural gas it carried. And finally, there's the possibility of leftover fluids and debris inside the pipeline from previous operations. All of these can accelerate the corrosion process.
It's like a perfect storm for corrosion. You've got the metal itself, the stuff that was flowing through it, and then whatever got left behind when they shut it down.
And it gets even more complicated. The report mentions something called a UWI severity score, related to restarting the well connected to the pipeline.
What is that exactly?
Think of it like this. When they fire up the well again, it's going to send a surge of fluids through the pipeline, almost like a shockwave. And that surge could dislodge any loose debris or corrosive substances that have been building up over the years.
So not only could we have pre-existing corrosion damage, but the reactivation process itself could make things worse.
Exactly. And with that potential for severe corrosion damage already lurking, this UWI score becomes a major concern. It means that the very act of turning the pipeline back on could trigger a failure.
So with all these risks, what can they do to mitigate this internal corrosion?
Well, the report recommends a multi-pronged approach. One key strategy is using corrosion inhibitors. These are special chemicals that act like a protective coating inside the pipeline, slowing down the corrosion process.
And how do they apply these inhibitors?
They use a technique called pigging, which, believe it or not, doesn't involve any actual pigs.
Wait, what?
I know it sounds strange. In the pipeline world, pigging refers to sending devices called pigs through the pipeline. These pigs are designed to clean out debris and apply those corrosion inhibitors we talked about.
So it's like sending a cleaning crew through the pipeline. But wouldn't that be a one-time thing?
Actually, the report recommends a regular pigging program. This means sending these cleaning pigs through periodically to keep the corrosion in check.
So they're not just cleaning up the mess from years ago. They're acknowledging that corrosion is an ongoing battle they need to fight, even when the pipeline is active.
Precisely. And they're not stopping there. Given the unique circumstances with this pipeline, the report takes things a step further. They recommend a specific type of corrosion inhibitor, known as a heavy filming batch-applied inhibitor.
Heavy filming. What makes this type of inhibitor so special?
It's designed to create a thicker, more robust protective layer inside the pipe, almost like giving it an extra layer of armor. Remember, we're potentially dealing with years of accumulated corrosion damage here.
Right, so it's like giving the pipeline a booster shot of protection after its long nap.
That's a great way to put it. And to ensure ongoing protection once the pipeline is up and running, they also suggest continuous corrosion inhibitor injection. They're really pulling out all the stops here.
It sounds like it. So they've got the inhibitors and the pigging to combat internal corrosion. But what about the exterior of the pipeline? Is that a concern too?
Good question. The report does address external corrosion, but they categorize the risk as low in this case. They note that the pipeline's coating and cathodic protection systems appear to be in decent shape, which is good news.
That's a relief, so no need to worry about the outside then.
Hold on. but the overall risk is considered low. The report emphasizes the importance of regular monitoring and maintenance. Remember, this pipeline has been out of commission for almost a decade. Even with a low initial risk assessment, things can change over time.
So even though the external corrosion risk is considered low,
Yeah,
they're not taking any chances.
exactly. They recommend regularly inspecting the coating, repairing any defects they find, and making sure the cathodic protection system is working properly.
Okay, so lots of focus on mitigating internal corrosion. But with all these precautions, are we ready to flip the switch and get this pipeline flowing again?
Not so fast. Before they can reactivate this pipeline, there's one more critical hurdle they need to clear, and that's where we'll pick up. After a quick break,
Okay.
we've been talking about all the ways they're trying to combat corrosion on this pipeline. Inhibitors,
Yeah.
pigging, even special heavy-duty coatings.
Right.
But it makes you wonder, if they're going to all this trouble now, why wasn't it done properly when they shut the pipeline down in the first place?
That's the million-dollar question. And it speaks to a bigger issue we see sometimes in pipeline management. What happens when short-term cost savings clash with long-term safety and integrity?
Because, let's be honest, properly prepping a pipeline for an extended shutdown takes time and money. But as this case shows, those shortcuts can come back to haunt you years later, sometimes with even bigger costs and risks.
Yeah, absolutely.
So before they even think about turning the gas back on, the report says they need to do one more crucial thing: an inline inspection.
An inline inspection, what is that?
It's a pretty sophisticated process where they send another type of pig through the pipeline. This one's packed with sensors. Think of it like a tiny, high-tech inspector crawling through the pipeline, taking detailed measurements and images of the pipe's interior.
So while those cleaning pigs are scrubbing away, this inspection pig is gathering intel.
Exactly. This smart pig can detect all sorts of issues that might not be visible from the outside. Things like corrosion, cracks, dents, or even changes in the pipe's thickness.
Why is this inline inspection so crucial in this case?
Because it gives a much clearer picture of the pipeline's internal condition
Yeah.
than any external inspection could. Remember, we're dealing with the potential for severe pre-existing corrosion damage. They need to know exactly what they're dealing with before they can even consider reactivating this pipeline.
So this inline inspection is like getting an X-ray of the pipeline's insides, confirming if those corrosion fears are real or not.
You got it. And it's not just about confirming the damage. It's about understanding the extent and location of that damage, because that information will determine what they do next.
What do you mean?
Well, if the inspection reveals significant corrosion, they have a few options. They could try to repair the damaged sections,
Yeah.
which could involve cutting out and replacing parts of the pipeline. Or, in a worst-case scenario, they might have to abandon the reactivation project altogether.
So it's a make-or-break moment for this pipeline.
It really is. And this highlights another key takeaway from this report: the importance of proactive pipeline management. If they had taken the necessary steps to properly mothball this pipeline back in 2015, they might not be facing these difficult choices today.
It's a reminder that decisions made years ago can have a ripple effect on our energy infrastructure for years to come.
Right. And it's not just about avoiding costly repairs or project delays. It's about ensuring the safety and integrity of our energy systems. Because a pipeline failure can have serious consequences for the environment,
Right.
the economy, and the communities they run through.
Absolutely.
So, inline inspection, that's the next big step. And depending on what they find, it could be a game changer for this whole reactivation project. Now let's shift gears a bit and talk about how they actually assess the risk of internal corrosion in a pipeline. The report mentions a 5x5 risk matrix. Will you unpack that for us?
Sure. A 5x5 risk matrix is like a tool that engineers use to measure the likelihood and potential impact of internal corrosion.
So it considers things like the types of fluids the pipeline carried, the materials it's made from, how it was operated in the past, and then spits out a risk rating.
Exactly. It's a way to systematically assess the potential for corrosion and prioritize mitigation efforts. In this case, the report classifies the internal corrosion risk for this particular pipeline as serious.
Okay, serious sounds concerning, but what does it mean in real-world terms?
A serious rating means there's a significant chance of internal corrosion happening, and if it does, it could have major consequences.
So we're not talking about a little bit of surface rust here. We're talking about the potential for leaks, environmental damage.
Right, and that's why the report emphasizes the need for all those mitigation strategies we talked about earlier. They're trying to address a very real and potentially dangerous problem.
And given the history of this pipeline, With a non-compliant shutdown and the potential for pre-existing damage, that serious risk rating becomes even more worrisome. It's like they're starting this reactivation project already behind the 8 ball.
Exactly. They're playing catch-up in a way, trying to mitigate risks that might have been avoided with proper management in the past. That's a great analogy, and it highlights why this case is so important. It's a reminder that pipeline management isn't just about what happens when the pipeline is active. It's about taking the right steps during shutdown and making sure you're not creating problems for the future.
Because as we're seeing,
Yeah.
those problems can come back to bite you years later, and sometimes with much bigger consequences.
Absolutely.
The whole deep dive has been really eye-opening. It's made me realize just how complex and potentially risky pipeline reactivation can be.
Yeah, it's definitely not as simple as just turning the valves back on. There's a lot of science, engineering, and careful planning involved.
And it seems like there's a lot we still don't know about the long-term impacts of shutting down and reactivating pipelines. It's a reminder that the decisions we made today about our energy infrastructure
Wow.
will have implications for years to come. We need to think long-term and prioritize safety and sustainability.
Well said. Thanks for joining us on this deep dive into the world of pipeline reactivation. We've learned a lot about corrosion, mitigation strategies, and the challenges of bringing a pipeline back to life after an extended shutdown.
And as we've seen, this case study highlights the importance of proactive pipeline management, informed decision-making, and a commitment to long-term thinking.
Absolutely.
We hope this deep dive is giving you some food for thought as you navigate the evolving energy landscape.
Thanks for listening.